the last section. Yay! All right. So you guys have a test coming up, and probably it's going to be Monday. So we'll have a review day Thursday, Friday. It's kind of so lame. Really, really hate that, but that's how it's going to be. All right. So today we're talking about some area of triangles. Hey, we want to be able to find the area of oblique triangles. So this is kind of an interesting thing here. A non-right triangle. If we had a right triangle, like, you know, something like this, then what is the formula for the area of a triangle?
Base times height.
1/2 base times height. Yeah, the area of a triangle is 1/2 base times height. So remember, from geometry, here's our base and here's our height. Height and base always have to be perpendicular to one another. And it turns out that, you know, it's just a half of a rectangle. And to find the area of a rectangle, we know it's base times height. That is the area contained in the rectangle, but our triangle is half that. And so if we have those nice perpendicular parts, the base and the height, then finding the formula for the area of a triangle or figuring out the area is really, really easy, okay? But maybe they don't give us that height, okay? So imagine we have a crazy triangle like this one, a triangle ABC here, and we don't know the height h of it. And so what we can do is pretty easily use some trigonometry to help us figure that out. So what we're going to do is we're going to imagine there's this height that we're going to drop in. We're going to drop in this altitude, and we're going to call it h for the height. And I don't know what it is necessarily, but maybe they did give me like a side length. So I know this value here. Maybe I know the sides of my triangles or something like that. So I have a couple of pieces of information here. So what I can do is imagine now I have this right triangle right here. And maybe I know this angle measure, angle C, okay? So the sine ratio looking from angle C would be, sine would be opposite over the hypotenuse here, so h over a. So the sine ratio looking from angle C would be h over a. And of course, if I want, I could get that h all by itself, times by a. Yeah, so I could multiply that a to the other side, and it turns out that the height is just a times the sine of angle C. And so what I can do then is say, hey, if I know a different way to get the height of my triangle, then I can take this information and, hey, plug it right in place of h. And so it turns out that if I want to know the area of some oblique triangle, if I have the right information, a couple of sides and an angle, then I can figure out the area pretty easily by doing 1/2 times the base, and then h we're going to replace with times a times the sine of the angle C. Okay? So just substituting that in there. So you can really do some interesting stuff to figure out the area here. And so what we can do here is we have here side, angle, side information. That's what we can use, this nice little formula. We want to find the area, round to the nearest tenth. So the area is, I'm going to write 1/2 AB times the sine of C. 1/2 AB sine of the included angle is what that is. And so we have 1/2 of 11 and 16 and the sine of that 105-degree angle. Super easy. Let's see. 0.5 times 11 times 16 times the sine. What mode should you be in? Degree mode. Is that a 0.5? That is weird. Okay, I got a colon. I didn't even know I could get a colon. Oh, okay. Funny. All right. Cool. So the area is 85.0. Let's see. We're talking feet. So this is square feet. How about that? That's pretty crazy. All right. Very cool. So again, let's see. Let's look at number 2. Again, side, angle, side. So area is simply 1/2 A times B times the sine of the included angle. 1/2 A times B times the sine of the included angle. Great. Plug that in your calculators for me. 106.8 inches squared. Okay, let's look at number 3. So easy formula, right? Pretty nice. Okay. Do we have the right information here on number 3? No, we do not. Okay. So we don't have the right information. We don't have side, angle, side. We need 2 sides and the included angle in order to use this fancy formula. And so, I need another side. Law of sines, very good. So maybe I want to figure out this side right here. And so we can use law of sines, very good. Law of sines. So sine of my angle 59 over its opposite side is equal to sine of my 76-degree angle over its opposite side of 7. And then how do we solve? Cross multiply. Okay, so I'm going to cross multiply here. So I get x times the sine of 76 equals 7 times the sine of 59. And then how do I get x by itself? Divide by the sine of 76. So x equals 7 times the sine of 59 divided by the sine of 76. And so what does x turn out to equal for me? 6.2. Beautiful. Okay. So we get a side length of 6.2. Now, in order to use my lovely little area formula, I need side, angle, side information. Side, angle, side info. So if these are my 2 sides, I have my side and my side. Where's the angle I need? How'd you get 45? Okay, 180 minus 76 minus 59. So, okay. So we needed the side, angle, side info in order to use our nice little handy-dandy area formula. So they have to be like sort of right around the circle. Does that make sense to you? Okay. So 3 things in a row, a side, an angle measure, and a side. All right, now we can use our area formula. So 1/2 my side. Ooh. Yeah, use the original decimal, definitely. I think in Delta Math, they would not appreciate a rounded thing. So you're going to want to go ahead and grab that answer. 6.1838, yada, yada, yada. Okay. So there's one side times the 7 times the sine of 45 degrees. So definitely go and grab that answer. I'm going to go ahead and do that just so we see. Sine of 76. Okay. So in my calculator, I'm going to do 0.5 times my answer above. So that's how I would do that, use the answer from above. And then times my 7 times the sine of 45. Oops-a-daisy. Oh, wow, I'm just goofing my stuff all over the place. All right, I get 15.3-ish millimeters squared. Good. Questions on that? No? Okay, super. Yeah, what's the question?
Why is it divided by 5? Like when you did it in red.
So, yeah, sorry, that's not divided by 5. It's just yeah, I just underlined the 6.2, okay. Yeah. So, thanks. Okay, good, let's turn the page. Okay, number 5. Who's Heron? I don't know. All right, number 5 here. Number 5. Again, I don't have the right information. I need to know this angle between my two sides. But I can't even find that angle yet. Yeah, Taryn?
Could you, instead of using that angle, could you use the Pythagorean theorem to find the other side way?
When can you use the Pythagorean theorem?
Triangle.
Only in it's a right triangle. Yeah. So I can't use the Pythagorean theorem. But it's a, novel idea. This side is probably... Yeah, so we can certainly... I would have to figure out this one first, because that's the side information I have. So I'm going to use law of sines again. So let's see. But I have to figure out this angle first. All right, so I have... wait a minute. This is the bad one, isn't it? Angle, side, side. Right? We can't do that? We can do law of sines, but this is the one that's ambiguous. So this is a caution case. We have to be really careful and make sure our triangle makes sense. Okay? So we can still use law of sines, but we have to do it very carefully. So sine of my angle x over its opposite side of 5 is equal to sine of my angle 85 over its opposite side. So I'm going to cross multiply. Actually, can I just multiply by 5? Okay, so sine of x is equal to 5 times the sine of 85, all divided by 11. And then how do I free the x? Inverse sine. Sine inverse of both sides. So sine inverse and sine cancel each other out. So I get a value for x of, let's see, sine inverse of 5 sine of 85 over 11. All right, so that's like 26.9 degrees. Okay, that seems reasonable. That is definitely making this triangle doable for me. Okay. What about this swinging leg thing? Do I need to consider that? Let's see. Remember, this leg could sort of swing in and create another triangle? So that other one would be 180 minus 26.9. So that would have been 153.1. Is that possible for... No. Why not? Because the 85 plus the 153 is too big. It's already over 180 degrees, so that second triangle is not possible. Good. All right. So just one triangle is possible here. Okay. Now we know that angle measure is 26.9. Now in order to use my area formula, I need to know this angle. So what is this angle going to be? 68.1. Good. 68.1. Okay, now I have my side angle side info, and now I can use my area formula. So we have 1/2 times my 5 times my 11 times the sine of the 68.1, that included angle. All right, what's the issue, Wyatt? Are you sure?
Yep.
Oh, I really want to know if there's a math problem.
How do you get 153.1? I know we did it yesterday, but I forgot.
So yeah, if you remember from when we did the law of sines, when we have this weird angle and a number here for a side info like the 5 and the 11, let's say. Remember, this angle at top is not we don't know what that angle up top is, right? And so it can swing and hinge and be sort of different. So this whole leg could swing in, creating a different triangle. So what was originally the angle here of 26.9, now it matches over here, 26.9. And then, but I need this side of that angle for my other triangle. So it's 180 minus the 26.9. And that's where the 153.1 came from. Okay. All right. Thank you for asking your question, because I really wanted to answer that. 25.5 centimeters squared. It's a good reminder. But yeah, this is just the other angle is 180 minus the 26.9 to figure out that other possibility, which was too big. Okay. All right. Let's look at number 6. Number 6, they gave us side info. So I need an angle measure in order to use my fancy little area formula. Oh, so I can just label an angle. All right, I can just pick one. Let's pick this one. So I want to find this angle, and so I have my angle and my opposite side like that, maybe? I pick an angle, and so what can I use to figure out that angle measure when we have side info? Law of cosines, yes, law of cosines. So 16 squared is equal to the other side squared plus the other side squared minus twice the product of the sides times the cosine of our included angle. Law of cosines. So we kind of bring everything together here, right? All the formulas that we've learned. Let's see. 16 squared is 256. And then 6 squared plus 14 squared is 232. I can multiply these numbers together. We get minus 2 times 6 times 14 is 168 times the cosine of x. And then what do we need to do? Subtract 232, yes. And that is 24 equals negative 168 times the cosine of x. And then we need to? Good, divide. So we get 24 divided by negative 168. Oh, my calculator wasn't on. Dang it. All right, we get negative 0.14285 equals the cosine of an angle. And how do we free the angle? Cosine inverse of both sides. Cosine inverse cancels out, and we get x equals cosine inverse of our answer. Good, 98.2 degrees. So now we have 98.2 degrees right in there, and now we can find our area. So it's going to be 1/2. If that's 98.2, I'm using my 6 and my 14 again. So 6 times 14 times the sine of that 98.2 degree angle. All right, and what do we get? Good, 41.6 square yards. Square yards. Good, good, good. So I am going to tell you what Heron's area formula is. Heron was a dude. They're always dudes. And this is just kind of a really random formula. There's nothing for delta math on this. Heron's area formula looks like this. The area equals, this is really weird. And I don't know where it comes from necessarily. It is a giant square root of s times s minus a times s minus b times s minus c. All of that is under the radical, so you're like, hey, what's the s? Where s is 1/2 times the quantity, A plus B plus C. This is called a semi-perimeter. Yeah, so A, B, and C. A, B, and C are the sides of a triangle, any triangle. And so if we find the semi-perimeter, you add up all the sides, divide it by 2. That's half of the perimeter. It turns out that the area is the square root of the semi-perimeter times the difference between the semi-perimeter and each side. All right, so just to see it in action here, let's figure out our semi-perimeter. Our semi-perimeter here on number 7 is 18 plus 21 plus 19, all divided by 2. Yep. So there's our 29 for our semi-perimeter, and if I want the area, then the formula is semi-perimeter, 29, times 29 minus the 18, times 29 minus, oh my goodness, 29 minus 21, times 29 minus 19. And I would just write it out like that, and then plug it in your calculator all at once. So 29 times 29 minus 18 times 29 minus 21 times 29 minus 19. Crazy. I forgot a 2. Oh, I sure did. Insert. Thank you. There, that's better. Okay, that's good looking. Hey, good looking. What you got cooking? Do you not know that song? I don't know. I think it was a jingle, actually. Okay. All right. So that's Heron's area formula. It's kind of really random, but miles square. But hey, it's amazing what they figured out 1,000 years ago. Right? Okay. Do you have questions for me?
No.
Okay. You guys have a delta.